To find the definition of the letter e, I begin by trying to find the derivative of an exponential function a to the x. So I use my derivative formula, I put in a to the x, and I will get the limit as h goes to 0 is equal to a to the x plus h minus a to the x over h. Since these two are being added to each other, I can separate them as a to the x times a to the h. So therefore I can factor out a to the x. Because there is no h in it, this limit as h goes to 0 will not affect it in any way. So I'll factor that out, a to the x, limit h goes to 0, and I'm left with a to the h minus 1 over h. So here is where the definition of e is going to begin. If this part over here, a to the h minus 1 over h, were something easy to deal with like 1, so if this were equal to 1, then the derivative would be really easy. It would just be a to the x. So what people did was sit here and think, well, is there a number that could give a 1 here for this piece? Just forget about the a to the x in the front. All I care about is there a situation where this part is equal to 1? And that is what this table over here is going to show. If I have bases 2 and 3, so 2 to the x and 3 to the x, what happens when h approaches 0? Well, 2 will get closer and closer to 0.693. This is accurate to 6 decimal places. And 3 goes to 1.098612. Now, neither of those is 1, but what it means is that there should be a number between 2 and 3 which the limit is equal to 1. Since the limit of 2 approaches 0.69 and the limit of 3 1.09, then logically there should be some number in there that the base as h approaches 0 will be equal to 1, and that is what the number e is. I can't remember what it's equal to, but it's some irrational number. But e is the base of the exponential function as h approaches 0 that is equal to 1. So this is the definition of the number e. The limit as h goes to 0, the number raised to the power h minus 1 over h that is equal to 1. So when I have e as the base, since this value is equal to 1, this part of this differentiation formula that we're trying to find is going to be equal to 1, so it's just a to the x, and since e is my base, then the derivative of e to the x, let me write it out properly. The derivative of e to the x is equal to e to the x. And that is because of this definition here. The limit as h goes to 0, the number raised to the power h minus 1 over h that is equal to 1. And that number was found to be the number e.